Hello everyone. So in the previous lecture we have seen central tendency to describe a dataset, and in this lecture we will be seeing measure of dispersion to describe a dataset. So why do we need dispersion as we already have central tendency? We will be seeing that in this lecture. So first, let's see a problem that actually made the need for dispersion. Let's say we have a data. Here I am calling it D1, and we have another data set that is D2. The mean of first data set is 0 and the mean of second data set is also 0. So can we actually have any idea how the data are in these two data sets? We cannot distinguish the data set, and there certainly is distinction as these are two separate data sets. These are not same. So how do we differ it? Let's say a department's CGPA is 3.5. The mean CGPA is 3.5 and another department's CGPA is also 3.5. But these are two different departments. Can we actually say how the students are in this department? Can you actually distinguish the two departments' students? We cannot. So that is why we need another measure, and that is called dispersion. So what is dispersion? Dispersion is how the data is spread around the mean. Let's see, suppose this is mean and the data are here. This is a spread, I'm calling it 1. And this is another spread and I'm calling it 2. So these two are certainly not the same. These data are closer to the mean and these data are far away from the mean. So there is certainly a significant difference in between these two. How do we measure it? That is why we need dispersion. And dispersion lets us measure that how far is your data from the mean. And we can measure dispersion in 4 ways. That is range, variance, standard deviation, and coefficient of variation. Let's see what is range. Think of this as a data set. Let's say this is the mean and these are the data. Let's say this is the maximum value of this is 70 and the minimum value of this is minus 60. So what the range will be, the difference between the maximum and minimum value. This will give us 130. So what this means is, this is 130. The data is spread within 130 unit. Let's say the range of one data set is 70 and range of another data set is 20. So we can say dataset 2's data are more closer to the mean, as the dataset 2 is spread within only 20 units and dataset 1's data are spread within only 70 units. So that is why dataset 2 is more closer to the mean. But in range there is a problem. Let's say these are the data and this is say 14 and this is minus 3. But here's an outlier and that is, let's say, 70. So the range will be this because of the outlier. But is it the actual representation? Is it the accurate representation of this data set? Because the data are here. The range should be this, not this. So for outlier, the range actually doesn't show the accurate representation of the deflection. So that is why we need another measure, that is variance. So what is variance? Variance is the average of squared differences between each data point and the mean. So variance is, let's say this is the mean and this is a data. The variance is, this is the difference 1. So the variance is defined by this. The variance will be d1 square plus d2 square plus d3 square divided by 3, their average. This will be the variance. So what this gives us? This gives us an average value. We can say this data set's variance is 7. That means on an average, all the data are deviated by 7 units from their mean. So the formula for variance is sigma square. Sigma square is defined variance. This is the data and this is the mean and this square, as the definition says, square differences. And this is the summation for all the values from I equals to 1 to I equals to n. And this is the n, the number of values. Now let's see some observations of this formula. Why is it squared? it is squared because we are concerned with the value, we are concerned with the distance, not with the negative values of it. We do not want to do any algebraic sum of it. So we only want the difference, we only want the average, we only want a value that will define that how much difference on an average it is from the mean. So that is why it is squared. So why not modulus? Because as we only want the distance, we could have just used the absolute value, we could have used just modulus. So why not modulus? Yes, we could have used modulus, and that is called minimum absolute deviation, which is this. So this is minimum absolute deviation. So this is not prone to outlier, and variance is prone to outliers as that is squared. If there is an outlier, that will actually give the value so high. So that is prone to outliers, and this is not prone to outlier. But the minimum absolute deviation is not used because till now all the measures we have done it for the sample, but we will want it for the population. What is sample and what is population? I've discussed it in my introductory video. So we want it for the population, so this is called inference. So with the minimum absolute deviations, with modulus, it is not possible to do the inference. It is possible to do the inference with the squared value, variance. So that is why we use the variance, not minimum absolute deviations. Let's see another measure that is called standard deviation. Standard deviation is just the square root of variation. Let's say we have a variance of 9. So the standard deviation will be 3. But why do we need the standard deviation? Because we already have variation. The standard deviation is needed because it is the same unit as the original dataset. We have a dataset age in year. We will have an average and we will have variance. Let's say the variance is 9. Let's assume the variance is 9. But the 9 will be 9 year square. We cannot say that how much year it is deviated from the mean from variance because it is year squared. So that is why to make it the same unit as the original dataset, we use the standard deviation because it gives us the same unit. So that is why standard deviation is used. Now lastly, we will be learning what is coefficient of variation. So till now, all the measures we have done it for only one column. All the measures, the mean, anything that we have done it for only one column. But let's say we want to compare it within 2 columns. Let's say this is column 1, this is column 2, and these data sets mean is 7, and this data sets standard deviation is 3, and this mean is 8 and standard deviation is 4. Now how do we compare this? How do we say that who are closer to the mean? How do we measure it? So that is why we need coefficient of variation, as the mean of these two are not same. We need to measure that how much it is deviated per unit mean. So if we calculate that how much it is deviated per unit mean and how much it is deviated per unit mean, we can actually have an idea of who is closer to the mean. So the deviation per unit mean is measured by mean standard deviation into 100, and the value is in fraction. That is why we measure it in percentage. So this is how coefficient of variation is measured. And let's say these data sets COV, coefficient of variation, is 40%, and these data sets coefficient variation is 60%. So we can say these data are more closer to the mean than this, because this is 60% deviated. So this is how coefficient of variation is measured, and this was the lecture of dispersion.